Oh, well, hello, my students. This is Mr. Kingsbury. Today we're going to look at synthetic division. This is part of our cubics unit here in Algebra 2. Don't forget to put the date in your period and my name on there. And I just realized I forgot to write down the essential question, which is going to be, how do I divide a polynomial by another polynomial using synthetic division? That's an excellent question. So synthetic division is another way to do some polynomial division. I feel kind of dumb saying that, but that's what it is. We've talked about long division, which you guys have done really well on. I've been very impressed. So we've talked about that, and that's kind of the no holds barred, always going to work method. However, in a few cases, actually more than a few, but in certain cases, we can use a faster method, which we call synthetic division. Now, here's, I guess, kind of the requirements. So in order to use synthetic division, the dividend must be a binomial. So to use synthetic division, one, the dividend, that's the thing you're dividing by, must be a binomial. That's two terms, no more, no less. And number two, the x must have a coefficient of 1. If it's anything else, we can't do it, at least for the purposes of this class. So if you're dividing by things like x plus 5, x minus 7, x minus 1, x plus 13, those are all good to go. But things like 2x minus 1, 7x plus 5, x squared plus 3x minus 4, or negative 18x, those are not going to work for a number of reasons. This has too many terms. This doesn't have enough terms. This has the right number of terms, but they've got coefficients in front of the x that are not 1. So those aren't going to work. So it's got to be stuff that looks like this. All right. If it doesn't look like this, if it's like this, long division it is. The process is pretty straightforward, actually. So first you're going to write everything out as a coefficient. So step one is write everything. No, I'm sorry. Write out problem using just the coefficients. And I'll show you how to do that. Then step two is you bring down the first coefficient. Step 3, multiply. Step 4, add. Step 5, repeat. Steps 3 and 4 until done. And right now you're going, Kingsbury, that makes little to no sense. I completely understand why you would say that. So let's look at some examples. What do you say? Let's see. I got a couple here. Let me bring them up really quick. Where did you go, examples? Okay, I had examples. Where did they go? Huh. Do. Weird. Ah, there's one. All right. So let's take x cubed minus 2x squared minus 8x minus 35, and we will divide that by x minus 5. That's cool. Alrighty, so like I said, first we're going to write out the problem using just coefficients. So here are my coefficients. I know there's not one in front of the x squared, but it's technically 1. We've got negative 2, don't forget the negative, negative 8, and negative 35. And I want to point out that my terms have variables whose exponents get smaller. What I mean is this is x cubed, x squared, x, and then a constant. We need to make sure all of those are in there. Now what I'm going to do is I'm going to draw an upside down division sign like this. And then I'm going to go over here and I'm going to do something kind of funky. You could just use the negative 5. I'm actually going to ignore the x. You could use the negative 5. If you did that, though, you'd have to subtract down. And what I find is that creates a lot of sign issues. So instead, I'm going to change the sign here. This is minus 5, negative 5. I'm going to change it to a positive 5. Then what that does is it allows me to add down in columns as opposed to subtract down. It helps me avoid sign issues, which is a wonderful thing and one of the biggest problems people run into. All right, next step, bring down the first coefficient. That's 1. Then we multiply. 5 times 1 is 5, and I'm going to put the result here. Then we add down. Negative 2 plus 5 is 3. Then we repeat. 5 times 3 is 15. Then we add down. Negative 8 plus 15 is 7. 5 times 7 is 35. We add and we get 0. And all that's left is we need to interpret it. Now, there's a couple ways to think about how to interpret this. One of them is if you started with x cubed, then your answer will start with the next one down, which would be x squared. Another way to look at it is that this is the remainder. This is the constant. This is my linear term. This will be my quadratic. And it gets bigger and bigger as you go to the left. So this is my constant, no variable, just x, x squared. And if it went on, x cubed, x to the 4th, x to the 5th, etc. So this would be 1x squared plus 3x plus 7. And since there's no remainder, I don't need to worry about any kind of remainders being tacked on there. So that's one example. Let me do a few more just to make sure that you've got this. And honestly, I didn't think I was going to use the next piece of paper here, so I'm going to get my notebook ready here really quick. I feel kind of like Superman changing into Super Booth. You're not supposed to see me do this, and yet here I am. Anywho, so let me just do a couple more examples. Example 2. Here we go. So we're going to take x cubed plus 2x squared minus x plus 5. And let's divide that by x plus 4. So first, I'm going to write all my coefficients. So that would be a coefficient of 1, 2, negative 1, and 5. Put my upside down division sign. I got x plus 4. So again, I'm going to take this and I'm going to change the sign. This was a positive 4, so I'm going to use, excuse me, negative 4. Just like on the previous one, it was a negative number and I made it positive. You're always switching the signs, always. We bring down the 1. Negative 4 times 1 is negative 4. And then we add 2 plus negative 4 is negative 2. Repeat. Negative 4 times negative 2 is positive 8. Add down 1 and 8 is 7. Negative 4 times 7 is negative 28. Add down, we get negative 23. So, remainder, constant, x, x squared. So this will be 1x squared minus 2x plus 7. And then this is my remainder, so I will go plus negative 23 on top. And I'm going to put this whole thing on the bottom, x plus 4. And that is synthetic division. Crazy, right? Let me do a couple more examples just to show you how to deal with a few things. At this point, we have discussed what to do if you're missing a term. So for example, if I said, hey, what's 5x squared minus 9 divided by x minus 2, my hope would be that you would look at this and go, hey, it goes right from x squared, the quadratic term, to the constant with no variable. We're missing a linear variable here. I would encourage you to rewrite this as 5x squared plus 0x minus 9. So we have x squared, just x, and then no x. That way then, you'll be able to do this correctly. If you don't put the placeholder in here, then when you do synthetic division, you'll get the wrong number. So let's write it with coefficients, 5, 0, and negative 9. And I've got x minus 2 as the factor I'm dividing by. This is a negative 2. So over here, I'm going to put a positive 2. And let's do the process. Bring down the 5. 2 times 5 is 10. 0 plus 10 is 10. 2 times 10 is 20. Negative 9 plus 20 is 11. So my remainder is 11. My constant is 10. This will be 5x plus 10 plus 11 over x minus 2. Pretty straightforward, right? Okay, let's do one more and then we'll call it a day. Example 4. I'm going to take 9x to the 4th plus 2x cubed minus x, and I'm going to divide that by x plus 8. And once again, I'm missing some terms. I got x to the 4th, x to the 3rd, no x squared. I got just regular x, and I'm missing a constant. I'm not entirely sure if I need the constant, but I'm going to put it in there. So we're going to rewrite this as 9x to the 4th plus 2x cubed. I'm going to put in an x squared term. I'm going to put in plus 0x squared. It doesn't change anything, but it gives me a coefficient to work with. Minus x, and I'm going to go ahead and put plus 0. We'll see if I need it or not. I have a feeling that I won't. But we'll put it in, why not? And then we'll divide this by x plus 8. So we rewrite it with coefficients, 9, 2, 0, negative 1, and 0. This is a positive 8, so I will put over here negative 8. That's what I'm dividing by. And let's go. Bring down the 9. Negative 8 times 9 is negative 72. 2 plus negative 72 is negative 70. Oh, this is going to be fun. Negative 8 times negative 70 is positive 560. And if I add down, I get positive 560 again. And oh my goodness gracious. Negative 8 times 560 is 0. 4, let's see, I write the 8. That's 8 times 6 is 48. Carry the 4. 8 times 5 is 40 plus 4 is 44. Oh my goodness. And that's negative. And when I add negative 4480 and negative 1, I get negative 4481. Wow. Wowie, wow, wow. This number got really big really quick, and I'm actually kind of worried that I may have messed it up. But, you know, what do? We'll just keep plugging on. So I'm supposed to multiply this by negative 8 again, I do believe. Wow. So we get 8. And 8 times 8 is 64, so put down the 4 and carry the 6. 8 times 4 is 32, plus 6 is 38, carry the 3. 8 times 4 again is 32, plus 3 more is 35. And a negative times a negative is a positive, so we'll add down, we get 35848. Holy guacamole. So if I did this right, working backwards, I should get x cubed. So this should be my remainder, constant, x squared, x cubed. Did it right. So we'll write this as 9x cubed minus 70x squared plus 560x minus 4481 plus, holy guacamole, 35848 over x plus 8. And that is a ginormous problem, but I did it right. Hopefully that works out great for you. We'll do some more practice in class. And I hope everyone has a great day, and I'll see you in class. Bye.